In today's lesson, we're going to talk about solving one-step equations and two-step equations. But first, we're going to start with one step here as a review, hopefully from the past. For example 1, we are given addition. And if you see the note at the bottom, you might want to write or jot this down, that you always want to do the opposite of your given operation on both sides of the equal sign. So I am given addition here. Addition next to my x value, and it's addition of a number next to that x value. Since I'm given addition, the opposite is going to be subtraction. So I'll make a note of that there. Opposite, subtraction. So with that plus 4, I will now move it to the other side of my equation by subtracting 4. That will cancel out that positive 4 minus 4 on the left side. What I bring down is just x that is left there on the left side. Bring down the equal sign as well. And then on the right side, I am doing the operation of negative 10 minus 4, which is going to be negative 14. Comes out to be my final answer there for example 1. In example 2, I am given subtraction next to my variable of a number here, and that is subtracting 8 from my variable. So I will do the opposite, which will be addition. What I do on one side, I have to always do to the other, so I will add 8 to both sides. That cancels out my negative 8 because negative 8 plus 8 is 0. Bring down the x, bring down my equal sign, and then do the operation of 5 plus 8, which is going to be 13. Next, we have a problem where we're given multiplication next to our variable. It doesn't look like it here, but when you have a negative 9 next to your variable, it can be seen or read as negative 9 times x. Very rarely you'll see the multiplication between the two. You'll just have them written next to each other. But know that when you have a number written right next to the variable, it is combined with multiplication there. So since I'm given multiplication next to my x value with a number, the opposite is going to be division. So each side, I'm going to get rid of that multiplied number by dividing it. That multiplied number will now come out to be 1 next to my variable. So I'm left with 1x, which we write as just x. And then on the right side, we have 18 divided by negative 9, which if you do your math correctly, will give you negative 2. In the last example, number 4, for our one steps, we are given division here. When I'm given division, it will look like a fraction bar and a number. Sometimes it can also be written as this with the division symbol itself, but a lot of times you'll see it with the fraction bar. So what I have to do is now the opposite of division, which is multiplication. That way I get rid of my divided by 2 that is underneath my variable, because I always want my variable by itself. And that means I have to get rid of the division by doing the opposite, multiplication. I multiply each side by 2. That will cancel out my 2 in the denominator, giving me just x left, 1x left, which we write as just x. And then 13 times 2 is 26 is my answer. Now moving on to two-step equations. In example 1, we have the work done for us, but I kind of want to go through it step by step. Step number 1 is locating the variable itself. The variable is always going to be the letter in your equation that you want to get by itself. So in this example, we have solve 3x plus 1 equals 7. We want to get x by itself, so we're locating that x. So I have to now, for step number 2, use those opposite operations to isolate that variable. I want that variable, like I said, all by itself. When you are solving these equations, this is an important step, but you always want to go in reverse PEMDAS order. So I'm going to be doing subtracting and addition first, then multiplication division, then exponents parentheses. So let's go ahead and do that. Here we have 3 times x plus 1 equals 7. Since I want to go in reverse PEMDAS order, I'm going to go ahead and move over this plus 1, this addition of adding 1 to my 3 times the variable. So, opposite operation of addition will be subtraction. That way, on this left side, I get my plus 1 canceled out with a negative 1 to become 0. Nothing's left there, and I drag down the 3x and solve 7 minus 1, which is 6. You always want to simplify as in step 3 after each operation. Don't keep that 7 minus 1 there. Do that operation out. From here again, you're thinking about opposite operations. So we're going to go ahead and have 3 times x there. Remember, when it's written next to each other, we have a slight multiplication between them. It's not always written, but it is multiplication between 3 and x. So we do the opposite, which is division. And what we do to one side, we have to do the other. So we divide each side by 3. Again, 3 divided by 3 cancels out to become 1x, which we'll write as just x there, but it's really saying 1 times x just for your reference. And then we go ahead and simplify our 6 divided by 3, which is going to be 2 there. Always, always, always think about your equal sign, separating your equation for each side when we talk about these both sides here. What I have to do one side, I have to do the other side of the equal sign specifically. Let's go ahead and get some practice with this with 3 practice examples of how to solve these two-step equations here. Think about those steps when we're solving these next 3. Example 2. Again, let's locate the variable. It's w. That is what I want to get by itself. In order to do that, go in opposite of PEMDAS, thinking about anything that's subtracted or added to that variable first, which would be the negative 14. Opposite operation of that subtraction will be an addition. That's the only way I can get negative 14 plus 14 to cancel out to 0. The plan is always to cancel those out to 0. If that doesn't happen, you didn't use the correct operation. We bring down everything that's left. The 7w, don't forget the equal sign in between the 7w and what is on the right side, which is 42 plus 14, which comes out to be 56. Again, still want my variable by itself. It is not yet. So now I'm going to do the opposite of that 7 times w multiplication between the two, which is division on each side. I divide each side by the 7. 7 divided by 7 comes out to be 1 w left. So that is a single w left on the left side. On the right side, 56 divided by 7 is 8. Over here for example number 3, same thing, locate the variable first. Then I'm going in reverse order of operation, getting rid of my 24. Now, there is no sign in front of the 24, so we know it's going to be a positive. It's going to be a positive 24. So when I'm thinking about the opposite operation, the opposite of addition is subtraction. So I will subtract 24 on each side. That cancels out to 0. As long as your negative 24 plus 24 cancels out to 0, you know you did the correct opposite operation. Bring down everything that's left on the right side, which is negative 4 times our b there. Don't forget that's multiplication. And then we go ahead and solve negative 12 minus 24 on that left side, and we get negative 36. Now we have multiplication that I have to undo here next to the b to get b all by itself. So I do the opposite of multiplication, which is division, dividing that negative 4 on each side. Negative 4 divided by negative 4 on the right side comes out to be 1 next to b. So you're left with 1b left. And then on the left side, we have negative 36 divided by negative 4. Remember, two negatives make a positive. 36 divided by 4 is 9. You also can write this in the reverse order since you might be used to that, b equals 9. We call that the reflexive property, but you can rewrite it. It says the same thing. 9 equals b is saying the same thing as b equals 9. Your variable is equal to that 9 there. Also, to make sure you double checked, you kept that equal sign throughout and did everything on those sides of the equal sign. You want to make sure whatever you do on one side of the equal sign, you do to the other. In example number 4, again, locate your variable. It is n here. We want to get that n all by itself. We go in the reverse of our PEMDAS. So think of anything added or subtracted to that n here, which is indeed the negative 9. We're subtracting 9 here. So we go ahead and do the opposite of subtraction, which is addition, on each side of our equal sign. So we add it over here on the left. You can't forget to add it to the negative 5 on the right there. Remember, what you do to one side of the equal sign, you have to do the other. Negative 9 plus 9 cancels out to 0. Good. Our goal is accomplished to move that negative 9 away from the variable. It's no longer next to it. It is moved. We bring down everything left, which is 2/3 times that n. Remember, you are multiplying it to the n there. Bring down the equal sign, keep it throughout because it's an equation. And then we go ahead and evaluate negative 5 plus 9, which comes out to be a positive 4. Now, because we have multiplication, we do the opposite of multiplication here, which is division. So instead of 2/3 times n, we have to get rid of it by dividing. What you do to one side, you have to do the other. 2/3 divided by 2/3, any number divided by itself comes out to be 1 there. We are satisfied with n by itself, 1n specifically. Now, on the other side of the equal sign, when I do 4 divided by that 2/3, I have to think back to my fraction operations. So let's kind of do an aside note down here. When I divide any time by a fraction, which I did here of 2/3, I then have to multiply by the reciprocal. The reciprocal is a fancy word for flipping it. So I take my 4 and then I change that 2/3 fraction to be the reciprocal or flipped. And when I do that, I also change my operation from division to multiplication. It's opposite. And I flip the fraction too. Now, really important that anytime you have a whole number, it can be written over 1 to mean the same thing. When I write 4 over 1 or say that it's 4, it is equivalent. 4 divided by 1 and 4 are equal. So I can interchange them accordingly, and I want to here. Because when I multiply by fractions, I multiply straight across the numerator and straight across the denominator. So 4 times 3 are in my numerator, it makes 12. 1 times 2 are in the denominator, it makes 2. From here, you always, always, always want to simplify. When I simplify 12 over 2, it becomes a positive 6. And that's exactly what is going to be on my right side of the equation.
In example number 5, we have a minus 9 all over 2 equaling to a negative 4. What we're going to do here first is get rid of the all over 2. Since it's division, the opposite is multiplication. What I do to one side, I must do to the other. So that's why I'm timesing 2 on each side. It cancels out on the left side with the division of 2, and it leaves me with the numerator of a minus 9. I have to equal it to what the result is on the right side, which is negative 4 times 2, a negative 8. From here, I'm going to go ahead and get, again, a by itself. So I will have to add 9 to each side because I must do the opposite to move it to the other side. That's going to cancel out the negative 9 plus 9, leaving me with just a on that side. And on the right side, I'll do the result of negative 8 plus 9, which is going to be 1. A equals 1 is my final answer. In example number 6, we have negative x over 3 plus 11 equaling negative 5. And I will start this one by getting x by itself. Easily movable is going to be this 11. Because it's a plus 11, I'll have to subtract 11 to move it to the opposite side of the equal sign. 11 minus 11 cancels out, leaving me with the x over 3. Now, with this negative sign, I'm going to place it on the 3 because you could put it in the top or the bottom. It'll be much easier to make it a negative 3. Then I do negative 5 minus 11, which is going to go ahead and be a negative 16. From here, I have x divided by negative 3, so opposite division is going to be multiplication here. So I'm going to multiply negative 3, and what I do to one side, I must do to the other here. The negative 3 cancels out with the division of negative 3 when it's multiplied, leaving me with just x on the left side, which is my goal. And then I do the result of negative 16 times negative 3 on the right side. That's going to be positive 48. X equals 48 is going to go ahead and be my answer here. In example number 7, we have Enrique made a mistake while solving the problem below. The mistake happens between step 1 and 2 here, and I'll kind of highlight what went wrong. We went ahead and had a division of negative 12 here from step 1 to step 2. That is not correct unless you also divide the negative 12 from 10, or if you do a different step first. So that's where I have over here on the right this prompt of, in your own words, identify the mistake he made. I wrote the following. He divided by negative 12 before he had only one term on each side of the equation. That would be the proper time to have used this. Then there's a prompt, explain how you would fix his mistake. And I answer with, I would have actually subtracted 10 from each side first here. That would have then allowed me to divide by negative 12 after. You could do this division of negative 12 that I highlighted, but you would have just had to do it to the 10 as well. That gets kind of messy, so that's why I would fix it by doing a different step first. In example number 8, we have some fill-in-the-box problems, and I'll show you how we can easily do them. We want to fill in the boxes so the value of A is 7. I'm going to go ahead and highlight that given information because I can actually replace this A with a 7 here. I will keep the subtraction and the equal sign. I'll bring those down. And then I love to start by choosing any number here. So I'm going to pick any number, and I'm going to choose 9, for instance. And I'm going to do the same thing in the next problem too. So I have 9 subtracted by 7. I love to answer my last box with the result of that. And hopefully you know that 9 minus 7 is 2. That's why I can fill in 9 and 2, and I could double check by solving this problem, which we know how to do now. So I have 9 minus a equaling 2, and I'll check my work. Because it's a positive 9, I'll subtract 9 from each side, cancels out on the left side, and leaves me with the negative a I can bring down. And the result of 2 minus 9 on the left side is a negative 7. When I divide by negative 1, because that really is a negative 1 next to the negative for a here, those cancel out to just a on the left side. And a positive 7, because when I divide two negatives, it makes a positive on the right. If you check and see here, the result had to be a being 7. So this is a perfectly great example. Let's try the next one, same way. So again, I'm going to start by reading fill in the boxes. So the value of x is negative 3. Highlighting what x is so I can replace it here. So where I have x in my problem, I'm going to replace it with a negative 3. I'll use parentheses this time because it is attached to, by multiplication, the box to the left here. I'll bring down the plus 5 and equal sign here. And then again, I will start using any number here. I'm going to choose a different number this time, so let's go ahead and use 6 as my first box number. Then again, I love after I replace one box and I have only one box unknown left, finding the result of what I just wrote here. I just wrote on this left side, and I'll highlight it in yellow here, 6 times negative 3 plus 5. Well, 6 times negative 3 I have to do first with my PEMDAS-GEMDAS order of operations, so that will be negative 18. When I add 5 to negative 18, I get negative 13 here. That's my result. And therefore, that's going to be what I fill in the very last box. So pretty cool how it works out that way. Again, let's check ourselves with writing what we just filled in those boxes. 6x plus 5 equaling a negative 13. I'm going to go ahead and use my skills that we learned in our video today by, instead of plus 5, subtracting 5 on each side. Cancels out on the left side to leave me with 6 and x. And on the right side, I actually solve what negative 13 minus 5 is, which is negative 18. From here, I can now finally separate the 6 multiplied to the x here, which means I divide each side by 6 because that's the opposite of multiplication. Cancels out to just x on the left, and negative 18 divided by 6 is negative 3 on the right. Again, how I know I did it correctly is if it matches what the value was in the given problem. X equals negative 3 is exactly what I needed.